Hello everyone, I am Dr. Prem Singh, Associate Professor in Mechanical Engineering Department, SKIT Jaipur. In this lecture, we will discuss about the design of cylinder for internal combustion IC engine. This lecture is related to the subject design of machine elements second. Before we start the design procedure of cylinder, the main parts of IC engines are highlighted. The main parts of IC engine are shown in figure. Given a cylinder. Cylinder is a stationary part of engine in which burning of fuels takes place. Connecting rod is the connector between piston and crank. Piston is the slider inside the cylinder. Crankshaft acts as a output shaft. Now start the design procedure of cylinder. Function of cylinder. Primary function is to retain the working fluid. Secondary function is to guide the piston. Material of cylinder. The cylinders are usually made of cast iron, cast steel. Requirements of cylinder material should be strong enough to withstand high gas pressure, should be strong enough to withstand thermal stresses, should be hard enough to resist wear due to piston movement, should be corrosion resistant. Design of cylinder. In designing of cylinder, following parameters have to be determined: bore or inside diameter D and length of cylinder, thickness of cylinder wall, thickness of cylinder head, size and number of studs. All dimensions can be seen in figure. Bore or inside diameter and length of cylinder. The dimensions of cylinder are calculated by using the following equations: mechanical efficiency equal to brake power or power available at crankshaft denoted by BP divided by indicated power or power produced inside the cylinder denoted by IP. IP given by equation as PM LA small n by 60, where PM is the mean effective pressure, L is the stroke, it is the distance between top dead center to bottom dead center, small n is the number of working stroke per minute, equal to capital N for 2-stroke engine, equal to N by 2 for 4-stroke engine. Capital N is the engine speed in RPM. Stroke to bore ratio L by D is determined from design data handbook that lies between 0.9 to 1.9. Length of cylinder is taken as 15% more than the stroke length due to clearance provided on both sides, given as LC equal to 1.15 L. Thickness of cylinder wall small t. The cylinder wall is subjected to circumferential or hoop stress sigma c and longitudinal stress sigma L. Longitudinal stress sigma L as shown in figure as calculated as sigma L equal to P max d square divided by d0 square minus d square, where d0 outside diameter of cylinder. Outside diameter of cylinder can be calculated as d plus 2t. Hoop stress sigma c is shown in figure, calculated as sigma c equal to P max divided by 2t into d. These two stresses act at right angle to each other. Therefore, the net stress in each direction is reduced. The net stresses are given as sigma L net equal to sigma L minus mu sigma c net equal to sigma c minus mu sigma L, where mu is the Poisson ratio generally taken as 0.25. Thickness of cylinder wall T. Cylinder wall is treated as thin cylinder and its thickness is calculated by following equation: T equal to P max into capital D divided by 2 sigma c plus c, where Pmax is the maximum gas pressure inside the cylinder taken as 10 times of mean effective pressure. Sigma C is the permissible hoop stress equal to permissible tensile stress for cylinder material. C is reboring allowance. It is required to compensate uneven wear on inner wall of the cylinder taken from design data book correspond to bore. Thickness of cylinder head Th is separate cylinder head or cover is provided in most of the IC engines to accommodate following parts: inlet and exhaust valves, spark plug, injector, air and gas ports. The cylinder head is assumed as flat circular plate and its thickness is calculated by following relation: Th equal to capital D square root of 0.162 P max divided by sigma C. The cylinder head is made of better material if factor of safety FOS and material is specified, then permissible tensile or hoop stress is calculated as sigma C equal to ultimate strength SUT divided by FOS. Size and number of studs. Studs are used to make leak-proof assembly of cylinder head, and gasket. In design of studs, following parameters are important: number of studs, Z, small z is derived from following relation: 0.015 capital D plus 4. Size of studs. Let the core and root diameter is DC and nominal diameter is small d. Core or root diameter is obtained by equating the gas force on cylinder head to the resisting force offered by all studs. Gas force is given by pi by 4 capital D square P mass equal to resisting force is given by small z pi by 4 DC square sigma T. Core and root diameter is calculated by following relation: capital D square root of P max divided by small z into sigma T, where sigma C permissible tensile stress for stud material. The studs are made of ductile material. If FOS and material is specified, then permissible tensile stress is calculated as sigma T equal to S by T divided by FOS. S by T is stand for yield strength for material. Relation between core diameter and nominal diameter is DC equal to 0.8 D. Pitch of studs. Pitch circle diameter dP is expressed as dP equal to capital D plus 3D. Pitch of studs is the ratio of pitch circle diameter divided by to the number of studs equal to dP by small z. This is all about the design of cylinder. Students are able to solve the design problem of cylinder. Thank you.